Hello. In this short tutorial I'm going to show you how to improve a little bit the performance of your microscope. Basically, anytime you are trying to see through a microscope a shiny objects, a metallical shiny objects like solder joints, radio frequency shields like this one, any other kind of shiny things on a PCB motherboard, what is happening is that you are losing a lot of details. And this is important, especially when you're looking for cracks in SMD component joints. Yeah? Or if you want to check for cracks around the component with hundreds of pins. What I've done with my microscope, and I'm still trying to search a very good solution which is in the same time very cheap. At the moment, I'm experimenting with a piece of film which I recovered from the back of a laptop screen. This is the one. This is called a diffuser sheet. It's used behind the laptop screen in order to diffuse the light uniformly. I attached a few some tape on it, and it's tape here, tape on the ring, and I try to see what's happening. As you can see with the light, with my improvised filter on the LED light, I can see a lot of details. Let me focus properly. Yeah, a lot of details on this piece of metal. While if I remove the screen, the image becomes a little bit more blurry. This is what my eyes are seeing. Maybe I'm mistaken, but for me, I think this works better. Now let me explain you what happens. Why is this phenomenon happens? Basically, every time you put a sample under the microscope and you have a ring attached to it, a light ring, the light from the LEDs are going in a straight line towards your sample. Yeah, it's perpendicular to the sample or a little bit angled, and it's reflected back into the microscope lens. And this is what is make your image cloudy. Yeah, this is called the glare of reflected parts. When you use a diffuser film, this glare is a little bit prevented, in my opinion, because what's happening, the film doesn't allows the light to come only in a straight line, but the light comes in very weird angles towards this way, this way, this way, not just parallel and come back to the microscope lens. This is why, in my opinion, details on the sample appear to be more clear. Yeah. Also, from photography, we know when you use a diffuser film on top of a light, that is reducing the very harsh shadows. So if you have any shadows on your object, the shadows will be eliminated. For example, if you're trying to see details on a printed circuit board, let me show you first what happens when you are, for example, check this capacitor. It's an electrolytic capacitor. You see, with the filter on, you can see all these metal lines. These are some details, yeah, on it, on the capacitor. The moment I remove the filter, yeah, check this out. Most of that lines are gone. Yeah, especially if you have a stronger light on the ring, on the light ring, that lines are gone. Let me put back the filter now, and the lines are back. The details on this thing are back. Let me refocus. Here I have the pins of a DDR3 socket. The moment you are trying to see any cracks in this connector, if you have a very bad light, um, a lot of reflections on the board, you will gonna get into trouble. Now, that is because the reflection creates a glare, and that glare is gonna prevent you from seeing any little cracks, any imperfections in the solder pads. This is the image that I'm working with, and it has a filter. The microscope ring has my filter attached, and this is what you can see when the filter is not there. For my eyes, this image is too shiny and it hides details on the solder blobs. Now with the filter on, for me the image looks more natural, with a little less glare. Keep in mind these pins are very small. Let me see something else. This is a. Let me go for a little bit of larger components so you can have an idea about it. Okay, here we have a little integrated circuit. No, let's go for a MOSFET, for a classic MOSFET. Yeah. Here is a MOSFET transistor. Let me focus. You can see I have the filter attached onto this on the rings, and for my eyes this is perfect. I can see if something is wrong with that. I can see any imperfection in the solder joint here. If any cracks appear, I will be able to see. If I'm taking out the filter, check this out. You see, I think for my eyes it's more shiny and the light is not very well distributed there. Now, you see the reflection. Check this paint. You see, without the filter, this part number paint, yeah, this one, this solder mask, is reflecting a lot of light and it appears to be very whitish. The moment I'm placing the filter, the light of the paint looks to be more matte. Again, this is a regular resistor. If you would like to see the cracks, this is the best way, because using a filter is the best way, because you will see any imperfection that could be alive here, anywhere here. Any imperfection would be very easy to see. Anyone. Also, if it's any kind of point or little hole in this resistor, in the body of the resistor, you will be able to see it just by inspection, without any problems. This is what you see with the filter attached. I love this this idea because it's very helpful. Also, using a filter is going to make your life much more easy when you're trying to read the component markings, like here, this transistor. Now, one moment. There are some ICs, not this one apparently, with hard, which is going to give you a lot of headache when you try to see what is written on the body of the components. In the future, I'm planning to buy something that people are calling polarizing filter. It's it's like a dark translucent piece of plastic. It's a very thin one. Uh, in my case, the one I want to buy, it's A4 shaped and it costs about £12. And I will do the same thing. I will cut it in the same shape like this one, and I will try to make it much. I will try to improve my view. If you buy the pieces of polarizing filter, you can use it even on lamps like this, for example. Yeah. This is a LED lamp with a magnifying glass on top of it, and you can place it filter sheet behind the glass, and it will help you very much with your life. I think that a piece of plastic is heat resistant, so it's not going to melt if it's very big, if it's going to be close to the LED, because as you can know that the LEDs kind of emit a little bit of heat. Thank you very much. This is for everything for today. Hope you're gonna see you very soon.